Yep. All right, so we're going to do this quickly so that my screen doesn't change hopefully too much. I feel like it's already turning purple. Does it look purple already? No, this is normal colored hands for me. Okay. I put two formulas on the top of the unit circle. We're going to try to do this quickly so that it doesn't change color. First one is going in this bottom left corner. That says arc length. That is an S equals R theta. I know that I hate using S, but this is the formula that everybody uses. And I also know that my S's look like 5s now, and it is not a 5, it's an S. Do you need something to write with? Yeah. You already got this down? Again, that says arc length is S equals R times theta. And then in the bottom right corner, it says area of a sector is 1/2 R squared theta. Did you sneaky copy my whole unit circle, Ryan?
I asked you.
Even the part that you don't need for...
No, I didn't cut that part. But I finished the front.
Nice. I think we've all finished the front now, haven't we?
Yeah.
Okay.
I took a picture when I asked so I could copy it down.
I think it's amusing. I'm not mad about you copying my unit circle. I like that you like to learn.
Okay.
I'm so mad about it. Ryan tried to learn things early. Yep.
Maybe put this on a Word document.
All of the unit circle?
Yeah.
Yes. Draw this on a Word document. I want to see how that goes. Are you talking about all the formulas? Oh, sure. Okay. Does everybody have both of the formulas? And we're the right color. Okay, let's move on. I'm going to show you how to use these formulas. Arc length and arc of a sector are both things that are used constantly, especially in GPS, which is kind of cool. Although one is more used in manufacturing and farming, and the other is more used in GPS, which I'll show you how. I've got a cool video I was thinking about showing you tomorrow. Has anybody ever seen the movie Contact? Great. It's about aliens. But there's a cool beginning scene that shows like the idea of sound waves or radio waves moving out from the earth, which I think is really interesting and a little bit of a mind-blowing idea, in my opinion. Okay. So let's start with this is 6.1, day 2. Today we're talking about arc length and sector area. All right, example 1. Go ahead and do your best to draw a circle. I mean, it's not the worst circle I've ever drawn, but it's not the best. Nathan, if you're not running to go get a compass right now, I'm going to be disappointed in you. All right. Anybody think they have the stupidest looking circle in this entire class? I'm giving a prize for this. the stupidest looking circle. You cannot draw a stupid circle on purpose right now. Anybody very disappointed in themselves with their circle? Yours pretty good?
Oh,
Mine doesn't want to erase.
mine took a couple pages.
You got a whole page? All right, anybody have an amazing circle? Nobody's willing to be amazing or horrible?
I'll give you an average circle.
Okay, give me an exactly average circle. It needs to be exactly average, though. Okay, there's Ryan's. Very average.
It's
Very,
not
very
good.
average.
It's not.
All right. Yours is better? Show me. Prove it.
Well, you can compare them.
We can. We can put them right next to each other underneath the camera. Let's do it. All right, there's Wyatt's circle. There's Ryan's circle. I don't know, hard to tell.
No, it's pretty tall.
Let's just make sure. I'm having problems seeing Wyatt's circle. Let's just get in there.
It looks pretty tall to me.
Did you run out of paper in like a different life and you're like, gotta make sure that we...
Oh, I just wrote it like that.
That's amazing.
I take it back. Mine's an above average circle.
Anyone's better than Ryan's? Show me.
Yeah, his look like
Wyatt, you so far win for worst circle of the class. Just because other people are, ooh.
Oh.
It's a little squarey. It's a little squarey. I would say Ryan's is more impressive, but I will say that I think that Wyatt's is a little worse than yours. But Wyatt, that's just because you made yours so small. Ooh, all right. I mean, they're leaning different ways, to be honest.
That's true. They look
But
like deer.
all right, I like George's better than I like Ryan's.
Very messy because it's a ball pen.
Oh, okay. It's messy, but look at that.
Oh,
I feel like that's too many tries.
It did be too many tries, but I mean, it's too many tries. It's too many tries, Sam, but man, it's pretty darn accurate once that. Oh, you want to be in? Chase, you keep on picking up your notebook. Ooh.
whoa.
That wins.
That's
Alondra.
A little smell.
And there's a smiley face right by it. Notice that you took double the amount of lines that Wyatt took. Actually, and a little bit extra there. Man, I think you're winning. All right. Alondra, do you want to go grab a prize? Thank you for starting it. All right. So now what you're going to do is you're going to draw.
I mean, I had two people worse and two people better. That's pretty average.
He did say he was most average. All right. So draw a picture like that. Oh, we're doubling up. This one is 3 pi over 8 in here. Looks like a Pac-Man that's eating 3 pi over 8. The radius is 18.2 centimeters. All right, now we're gonna try to have an intense moment here. So everybody put your stuff down and look up intensely. I'm gonna not look at you for a second, and when I look up, I want you to be looking at me very intensely, not angrily, intensely, like you are fascinated. Ready? I mean, some of you are fantastic, and Natalie looks more bored than she has ever been in her entire life. I look up and Natalie's doing this. Just like, please, die right now. Okay, S is the arc length. This side is the arc length. I'm going to write S over here. Like, here is S. This part is S. That's squiggles. Squiggles is S. So you take the radius times the angle, but the angle has to be in radians. All right, I'm going to try to explain where this comes from. Do you remember that when we took the yarn, we took that piece of the radius and we started wrapping it around the edge, right?